Occasionally, we come across laser sensor specifications in which there's reference to something called peak power as opposed to average power. These are two different parameters, and since a laser can have, for example, an average power of 1 watt and yet a peak power of 1 megawatt, it's rather important to understand the difference. Power is a measure of the rate of flow of energy. A typical unit would be 1 joule per second, which we call 1 watt. When describing a CW laser beam, we can't talk about energy, but rather only the rate of flow of energy, so power is a straightforward term there. When describing a pulsed beam, though, things can start to get confusing. Consider the following simple example and you'll get the idea. This laser is on for 1 second out of 5. During that 1 second, its power is 10 watts, but for the other 4 seconds, the power is 0. The average power is actually only 2 watts, but the power during that pulse is 10 watts. The energy of a pulse divided by its width, in other words, the power during the course of the one pulse, is the peak power. So you might have a laser emitting 1 joule pulses at a rate of 1 hertz. The average power is simply 1 joule times 1 hertz, or 1 watt. But if the pulses are 1 microsecond wide, the peak power, the power during the course of a pulse, is 1 joule divided by 1 microsecond, or 1 megawatt. 1 watt, 1 megawatt. Big difference. Why, you may ask, are there these two different terms for describing laser power? In many cases, it has to do with damage threshold, the ability of a sensor to survive the experience of measuring a beam that it's placed in front of. Sensors can be damaged in many ways, and one of them is too much energy per unit area, or energy density. Laser pulses of even moderate energy can, when focused down to a small enough spot, be used for welding metal and drilling holes in silicon wafers. It's important to understand, though, that when a laser pulse is long, say a few milliseconds, the heat produced in the sensor due to absorbing the beginning of the pulse has some time to move out of the way before the end of the pulse arrives. The sensor's absorber can therefore handle higher energy density for long pulses than it could for shorter pulses, where there's less time for heat propagation and all the generated heat remains concentrated in a very thin layer of surface material. If you look carefully at our sensor data sheets, you'll notice that there are two damage thresholds: maximum power density and maximum energy density. As opposed to maximum power density, which is usually a simple number in kilowatts per square centimeter, maximum energy density is usually portrayed as a table with several possible values in units of joules per square centimeter for several different pulse widths. The maximum energy density depends on the pulse width, as we just explained, because a longer pulse width allows more time for the generated heat to move out of the way. We frame this as a derated maximum energy density for very short pulses, simply to stick to terminology that's most practically useful to most users. But one could just as easily look at it as a sliding scale of energy densities to ensure that a given peak power is not exceeded. How can one measure the peak power of a pulse? Ophir has a fast photodetector called the FPS-1, which can show you your laser pulse's temporal profile on an oscilloscope. Since the scope does not display a trace of absolute power output over time, but rather the relative pulse behavior and shape, it cannot be used directly to find the peak power. However, with a simple calculation, the trace may be used to derive the peak power of a pulse by simply dividing the pulse energy, measured by a suitable energy sensor, by the pulse width, taken from the scope. I should mention also that if your pulse shape is complex and the width is not obvious, there's a quick and dirty trick that you can use to get a very good approximation. It's described in detail in the tutorial How to Measure the Peak Power of a Pulse Laser, which you can find at the bottom of the FPS-1 page on our website. For more information, please contact your local Ophir representative or visit our website.